Hello everyone, welcome to the DISL weekly seminar. My name is Hyangsuk Min, and today I will be introducing 3 recent papers that investigate how large language models handle multi-document tasks. Specifically, we will explore how LLMs perform in multi-document question answering, conditional reasoning, and summarization. Here are the 3 papers I will be discussing. First, leave no document behind. Benchmark and long context LLMs with extended and multi-document QA, which is published in EMNLP 2024. Second, MDCR, a dataset for multi-document conditional reasoning, which is also published at EMNLP in 2024. The third one is From Single to Multi, how LLMs hallucinate in multi-document summarization. The first paper is about a benchmark for multi-document QA, and the second paper is about a multi-document conditional reasoning, and third is about exploring LLM hallucination in multi-document summarization. So let's begin with the first paper. The first paper, Leave No Document Behind, focuses on designing tasks for multi-document QA. So real-world questions really come from a single document, which means that LLM needs to handle scattered evidence. This paper highlights 3 main challenges: collecting partial information from multiple documents, maintaining logical consistency, and performing multi-step reasoning. Their overarching goal is to create a benchmark that tests a model's ability to combine relevant details from multiple documents. Next, look at how the authors approached this. To test multi-document QA, the authors create a benchmark that supplies 11 documents for each question, each from domains like legal, finance, and academia. Because no single document is sufficient, the model must piece everything together. They propose 4 tasks, each requiring different types of cross-document reasoning. They propose spotlight locating, comparison, clustering, and chain of reasoning. The detailed description about 4 tasks are described in the given figure. Spotlighting locating is to find the answer in one document among multiple documents. The comparison is to find the answer by collecting the relevant information and comparing them across multiple documents, and then they get the answer. And the clustering is to generate answers by gathering the relevant information across multiple documents and grouping them according to a given conditions. Chain of reasoning is to make the answer by referencing the multiple document and track the information, and they get the final answers. And they conduct a multiple experiment, and the notable finding is that the simpler the spotlighting locating task scored higher, suggesting that combining multiple documents for a single answer is still quite challenging for current LLMs. Despite providing a solid benchmark, this paper doesn't dive deep into why models fail or reasoning paths they take. Understanding these internal processes could reveal whether the model is genuinely reasoning or just guessing. That kind of analysis isn't covered here, but it's an important avenue for future research. Let's move on to the second paper. The second paper introduces MDCR, a dataset designed to test how well LLMs handle multi-document conditional reasoning. In real-world scenarios like scholarship, regulations, or job qualifications, they often span multiple documents. So this paper aims to measure how LLMs manage and/or logicate relationships and conflict and implicit conditions when no single document has all the answers. So they create the dataset to evaluate LLM's ability to reason over conditional relationships across multiple documents. The authors collect documents from domains like scholarship and job postings, then manually annotated condition relationships. They also generated scenarios where a user must satisfy multiple conditions. And here is the detailed description about benchmark data set. As shown in the figure on the left, there are 3 documents about scholarship eligibility. In the first human annotation phase, the annotator have to make a label about its conditions. So they have to find the condition within the document, and then they mark that these 2 conditions have and or relationship, like they have to mark the Boolean relationship within documents. And then upon the generated scenarios, they have to mark condition relationship across documents. For example, in the second document and the third document, there are C3 condition and C5 condition, and the annotator look at these 2 conditions and mark that they are inclusive equivalent conditions. So, given the generated data set, here are the full scheme of the given benchmark data set. They provide 3 inputs to the model, such as multiple document, and user scenario, and user questions. Using these 3 inputs, the model have to make the answer by reasons across multiple documents like this. And then they make an output. They make 2 outputs. The first one is short answers about what is the max number of scholarship attainable. And the second one is conditional answer that meets this user questions according to user scenario. To evaluate the model performance, they compare multi-document settings in multiple ways. First, they provide diverse hints such as document condition, condition set disability, and condition relationships. So they increasingly provide different hints, which makes the model's reasoning process easier. And they compare the model performance across them. And the second, they develop 3 different user questions by increasingly develop the reasoning difficulties, such as in the first, they ask, does given document meet at least one condition? And then they ask, does it meet all conditions? And they ask the model to find the optimal number of conditions the user scenario can meet. In the first experiment, they conduct a reasoning process without any hint, and then they provide different 3 hints, and then they provide all 3 hints. So this result shows that LLMs make quick decisions, like they achieve 5-7% accuracy in short answer accuracy, but often lack reasoning accuracy, like to find the conditional answers, which means that they struggle with implicit conditions. And the results shows that the additional information document and condition relationship improve performance, like as shown in this figure, that the accuracy is increasing, but multi-document reasoning remains still challenging because the accuracy is not that high enough. The study tested various question types, whether at least one condition is met, whether all conditions are met, or how many can be met. LLMs did best on simpler questions, like where all conditions are met. But more complex tasks such as whether at least one condition is met and how many can be met require detailed optimization, or detecting contradictory conditions shows lower scores than the simpler one. Unsurprisingly, the second question achieves better performance than other two questions. It's because that if any condition is unsatisfied, then model can take a shortcut signal if there are one condition is not met. And the author also investigates the error types. In the first law, we can see that LLMs struggle to consider inter-document conflicting conditions because they show 47% errors compared to other three. In the second row, it shows that LLMs struggle to extract and evaluate eligibility conditions, which results in incomplete or inconsistent answers. So the limitations include focusing mostly on yes or no short answers without broader question types. So future work could expand domains or analyze hallucination in conditional reasoning, or so we can expand the short answers to the longer answers, such as explain context, recommend steps, or provide optimal choices. Let's move on to the third paper. This paper explores how much and what patterns of hallucination appears when LLM summarize multiple documents. Summarizing multiple source documents can be tricky, especially when they are about conversations and they have the conflicts or incomplete details, which makes the hallucination more likely. In this paper, they identify patterns of hallucination in multi-document summarization and explore mitigation strategies. In the paper, they experimented with summarizing news and conversations while gradually increasing the number of documents from 2 up to 10. They also conduct 2 separate experiments, summarizing the all content related to the subtopic, or summarizing the shared content related to the subtopics. And they tried for mitigation techniques like rule-based summary reduction, prompt refinement, but in the paper they shows that these methods have limited effectiveness. So the paper identifies 4 major types of hallucination that occur in multi-document summarization. Since the task in this study focuses on evaluating summaries with correct answers, the types of hallucination observed in this context appear to be different from those in typical scenarios. The 4 types of hallucination the paper introduces are pedantic, which is focusing too much on high-level details, like they don't add no new information or no new insights, or they provide insights but which are overly generic or overly specific information. Second one is instruction inconsistency, which the summary contains unrelated to the subtopic, redundant or not shared, violating the conditions specified in the prompt. The third one is context inconsistency, which means the summary misinterpret certain details provided in the document. The last one is fabrication, which contradicts or which is not supported by the information presented in the provided document. The third one is kind of hallucination, defined in single document summarization setting. In this paper, they manually expect hallucination in the generated insights. However, due to the cost of human labor, examine hallucination in on 2 document pairs. In the research shows that the first pedantic error occurs more than 50% in the first setting, while in the second setting, to find out share the topic across multiple documents, it shows more than 70% hallucination in instruction inconsistency error type. They also conducted experiments about comparing the summarization performance based on the number of documents. And the research shows that as the number of documents increases, the error rate increases, and with the trend of being especially pronounced in conversation domain. In the news domain, the error rate is from 20% to 52%, while in conversation domain, the error rate is from 45% to 75%, which is much higher than the news domain. They also shows that summaries that integrate information shared across documents show an error rate that is about 5 to 10% point higher than those summarizing individual pieces of information. And the model tends to generate summaries when there is no relevant content to match the given conditions. The proportion of unnecessary content generated varies depending on the model, with some models generating up to 80% of irrelevant content. Additionally, when examining where errors occur in the summary during multi-document summarization, it was found that errors become more pronounced towards the end of the sentence. Interestingly, the number of documents did not show a significant correlation with the error rate. In this paper, they used an insight-based approach, which might overlook more nuanced semantic errors. And I think the future work could explore multi-dimensional evaluations, handle conflicting equivalent information across documents, and develop better ways to detect or prevent hallucinations. In conclusion, these 3 papers highlight that LLMs face significant challenges when information is split across multiple documents, whether the task is question answering, conditional reasoning, or summarization. This opens up many opportunities for developing more robust benchmarks and methods that accurately reflect real-world multi-document demands. Moreover, efforts should focus on improved reasoning, error mitigation, and deeper analysis of how models combine evidence. Thank you for your attention, and I'm happy to take any questions. Thank you.